Hi, my name is Lewis Redfern, and I'm a fifth-year graduate student in the Farha lab here at Northwestern University. In my research, I make new catalysts that enable chemical reactions that are very slow or challenging. One of the chemical processes that I work on is the reduction of acetylene to form ethylene gas, which is an important molecule in forming many of the plastics that are ubiquitous in our modern society, like polyethylene in plastic bags. Let's look at the reduction of acetylene more closely. If we add up the oxidation state of all the atoms in acetylene, we see that the hydrogen atoms are in a +1 oxidation state, while the carbon atoms are in a -1 oxidation state, which adds up to give us a neutral molecule. In order to reduce this molecule of acetylene, we can think about reacting it with another molecule of hydrogen gas. If we look at the oxidation states again, we can see that all 4 hydrogens have a +1 oxidation state, while the 2 carbon atoms have a -2 oxidation state, which is lower than before. This process is known as reduction. Remember how, in order for one molecule to be reduced, another molecule has to be oxidized? In this case, the acetylene is reduced, which means that the hydrogen molecule must be oxidized. If we count up the oxidation states in the hydrogen molecule, we see that both hydrogens are at a 0 oxidation state, while in the product of ethylene, once the hydrogens are attached to a carbon, their oxidation state has increased to +1 in a process known as oxidation. Now, one of the challenges with this reaction is that the desired product, ethylene, can react with another molecule of hydrogen gas to form ethane gas, which is not as useful for making plastics. This is where my research comes in. In our lab, we make new materials called metal organic frameworks, or MOFs, and we use them as catalysts for these reactions. You can think of these MOFs as molecular tinker toys, or connects, where individual metal ions, or clusters, are connected by these organic linker molecules. I work on tuning the chemical properties of these materials so that they react very quickly with acetylene gas and very slowly with ethylene, so that we can form ethylene without producing ethane.